Before the 20th century, the term matter included ordinary matter composed of atoms and excluded other energy phenomena such as light or sound. This concept of matter may be generalized from atoms to include any objects having mass even when at rest, but this is ill-defined because an object's mass can arise from its, possibly massless, constituents' motion and interaction energies. Thus, matter does not have a universal definition, nor is it a fundamental concept in physics today. Matter is also used loosely as a general term for the substance that makes up all observable physical objects. All the objects from everyday life that we can bump into, touch or squeeze are composed of atoms. This atomic matter is in turn made up of interacting subatomic particles, usually a nucleus of protons and neutrons, and a cloud of orbiting electrons. Typically, science considers these composite particles matter because they have both rest mass and volume. By contrast, massless particles, such as photons, are not considered matter, because they have neither rest mass nor volume. However, not all particles with rest mass have a classical volume, since fundamental particles such as quarks and leptons, sometimes equated with matter, are considered point particles with no effective size or volume. Nevertheless, quarks and leptons together make up ordinary matter, and their interactions contribute to the effective volume of the composite particles that make up ordinary matter. Matter exists in states or phases, the classical solid, liquid, and gas, as well as the more exotic plasma, Bose-Einstein condensates, fermionic condensates, and quark-gluon plasma. For much of the history of the natural sciences, people have contemplated the exact nature of matter. The idea that matter was built of discrete building blocks, the so-called particulate theory of matter, was first put forward by the Greek philosophers Leucippus (490 BC) and Democritus (470–380 BC).